Okay, so you've got the formula on the sheet. Let me just explain this here really quickly to you. So notice, so what is happening is they're subtracting the terms here, the second term minus the first, the third minus the second. So they call that the common difference. You're going to do the same exact value every time you subtract. Now, subtracting, addition, adding a negative, personally, I'm quicker at adding. I just look at the terms from the first to the second and figure out what's going on. Are you going up by 2? Are you going up by 3? Are you subtracting 7? What's that? What's happening? Whatever the difference is, they call it D, the common difference. Very fancy here. So write the first 5 terms of the sequence. We've done that before a million times. Put 1 and 2 and 3 and 4 and so on and so forth. Determine whether or not it's arithmetic. If it is, find the difference. Okay, doesn't tell me to start with anything besides anything but 1. No note about 0 or anything.
Is this what arithmetics do?
Oh, goodness.
I thought you were an arithmetic.
And act.
Okay. Now, some of you, of course, can just do this a little mental math style, obviously. I'm going to jot it out. We're going to put, of course, 1 in first for n. So 150 minus 7. That's easy enough.
143.
Alex got it quick on the draw there. Let's put 2 in for n. So 7 times 2 would be 14. What's 150 minus 14?
Oh, so I did the math.
Oh, heavens. Okay, 150 minus 7 times 3, or 150 minus...
129.
Clearly we got it. What's your 4th term?
122.
5th term?
115.
Okay. So here is the next question for you. I've just taught you absolutely nothing new there so far. Take a look through the terms. Are you consistently going up or down by the same amount?
Subtract 7 every
We're
time.
subtracting 7 every time. So that is called our common difference. And it also has determined whether or not it's arithmetic. I guess I'm going to say yes, it is for something exciting. All right, same deal. Let's figure out our first 5 terms, and then we'll decide if it's arithmetic. All right, put 1 in, of course, so 2 to the 1 minus 1, or 2 to the 0. Then I'm going to have 2 to the 2 minus 1, or 2 to the first.
No.
Then I'm going to have 2 to the 3 minus 1, or 2 squared. 2 to the 4 minus 1, or 2 cubed. What's 2 cubed? And what's your last term?
16.
Okay. Now, next question. Are you, keyword, adding
No.
or subtracting the same amount every time? Nope, it is not arithmetic.
That's what that means? If there's
So
a
therefore,
common
there's no common difference. Now, there is a pattern. What's the pattern? You're doubling. You're multiplying by
You know I had
2.
double it.
So, all right, so I specifically threw this one in as a little preview of the next section. The next section is geometric sequences. Geometric sequence, you multiply between the terms or divide. Okay? So, and there's different formulas for those. That is for tomorrow. All right, so you've got the formula on the sheet. So, of course, what's important, or why we like to write the formula, what if I said, hey, I want you to write out or determine for me what's the 107th term? Well, I'm not going to keep going after the first 5 and write out to 107. I don't have that kind of time, people. So this is where we're going to use our formula. So A1, of course, is your first term. N is whatever term I'm asking you to find. If I want the 107th, I put 107 in here. And then D, of course, is that common difference, what you're adding or subtracting by every single time. So find the common difference. Okay, all right, figure that out for me. What's your common difference? Difference is? -6. They're going down by 6. Okay, then it wants the first 6 terms. Well, I wouldn't sweat this. We've got the first 4 up there. I think I can subtract 6 a couple times, right, and not get too carried away. So if I subtract 6 from -5, what would be your next term? -11. And your next term?
17.
Okay, so I'm not going to get any more carried away than that for the first 6 terms. I mean, why would I? I do not want to make the list out to the 300th term. We do not have that sort of time. So I'm going to use the formula. Formula is the first term, which clearly is 13, plus n minus 1 times our common difference. Difference -6. Now I'm going to put -6 in parentheses just because I don't want it to look like -6. Now, once you have the formula, you can get me any term I ask you for. I want the, Lord help us, the 300th. Must have been feeling feisty when I made this one.
Should have
And then obviously I'm going to type that right into your calculator. I'm not going to get it carried away with it. All right, punch that in and see what you get for the 300th term. It's going to be a big number.
Let's see what I get.
Negative 1,781.
Negative 1781. Got it.
Hey, I was gonna say. Yeah.
Ooh.
No, you should have just said it.
Ooh, you gotta be quick. Oh
Negative
no.
17.
Yeah.
Any questions on how to type that in your calculator? We got it. Good. Okay, flip the page. Here we go. Oh boy. Okay, find the formula for the arithmetic sequence. Oh boy. Okay, so formula. That obviously formula sheet. Now this one's pretty nice because they flat out gave you everything you need for the formula. The first term, n minus 1, and the difference. Now, personally, and because I like to be nitpicky about stuff, I would always have on a quiz or test that I also want this simplified. Because there are like terms that you could put together in there once you distribute -8 through.
Oh my god.
So let's clean it up like good mathematicians would. -8 times n.
Just per se, take points off.
Yep. And then I'm going to make it -8n. I'm going to combine 100 and 8 together.
I hope I don't forget.
I have a little note that says simplify.
Thank you.
And again, the nice thing about once you have the formula, you can easily get any term. I mean, last time I was mean and asked for the 300th. If I needed 300th again, I just throw a 300 in. Not a big deal. So getting the formula is pretty important. Okay, still easy, but the info's not quite as obvious. First term is,
I'm not gonna lie.
okay, fractions, here we go. What's the common difference? What are you subtracting off every time?
A half. 1.5. 1, 2.5.
Can we
It's a
maybe
half.
like land on an answer?
Did you just say it's a half?
I heard a half, I heard 1.5, I heard 2.5.
Oh.
Negative 2.5.
-2.5, they're decreasing by -2.5. I'm getting scared now.
I can't do mental math.
And again, I just put it in parentheses because it's a negative. I don't want that to look like subtraction. And let's simplify. Because there's some like terms in here. We can combine now the 4 and the 2.5 together. I like the variable term first. It really doesn't matter. It's just how I like to roll. Got it. And again, we like to practice or make sure we can really generate the formulas, because now if I asked you for any term, piece of cake, throw that number in and get it. Okay. All right, let's take a look at the next thing. The 11th term of an arithmetic sequence 52, and the 19th term is 92. Woo, the 1000th. Ooh. Okay. All right, we got it. So I like, that's kind of wordy to me. I mean, that's the math person in me. So the 11th term, so A11 is 52. I like to look at it in numbers. That's just how my mind works. And then, of course, the 19th term, okay, 92. So, of course, to get our anything with arithmetic sequences, what's most important is that darn common difference. So I'm going to work on that. So, of course, for the difference, I'm going to subtract those. I mean, we can subtract that in our head. So the difference from 92 to 52, obviously it goes up by 40. Okay, but wait a minute. That is from the 11th to the 19th. I want to evenly scale it for each term. How many terms are there between 11 and 19? 8.
Oh, right.
So there's my common difference. Now, we still need to come up with the 1000th term. So again, I want to generate the formula, because once I have the formula, I can find you any term you want. Now to get the formula, choices here. Formula, we start off with the first term. I mean, 11's not awful, but I can't say as I want to go the opposite way. I want to subtract 5 for the 10th term. Subtract another 5 for the 9th. Subtract another 5. Blah, blah, blah. That's kind of irritating. So I'm thinking about my formula. A1 is what I'm really after. N minus 1. I've got the 5. So what I'm going to do here, I'm going to pick the smaller number. It doesn't really matter which one you use. Meaning I'm going to pick A11. I'm going to work off this guy. Just because it's smaller, you can use either. So I know the 52nd term. So I'm going to put an 11 in here for n. So I know my 11th term is 52. And I'm like, oh, Okay, well I can go through that and now solve for the first term. 10 times 5, 50. What's your first term? 10 times 5 is 50. 2. Now I can make my formula. Now I can throw 1,000 in there and we can get this figured out. So I'm going to write my formula out first, nice and pretty. First term, n minus 1 times our difference. Now, I'm not asking you for the overall answer of the formula. So honestly, I can't believe I'm going to say this. I'm not going to simplify it. I'm not going to distribute it. Oh, because I think finding the thousandth is challenging enough. So 1,000 minus 1 times 5. So you have to punch that into your very lovely calculator. So what is your 1,000th term? That's a big number.
4997.
You got it. So it's still easy, but sometimes they don't give you like super obvious information. So getting the difference was easy. Subtract, divide by how many terms. But then I had to get a little creative to come up with the first term so I could generate my formula. I clearly was not going to write out to 1,000 terms. Nobody's got time for that. Hey, let's practice recursively defined again. Now, recursively defined, next term relies on the previous term. That is all this little crazy subscripts. So they give you the first term, of course, is 6. All right. And it says first 5 terms. Okay. All right, I'm on it. And it's important we understand these subscripts, especially when we get to our proof section, mathematical induction. Which is more, k plus 1 or k?
K plus 1.
K plus 1. So this is saying to get your next term, the higher term in the sequence, it's the last one plus 5. Oh, okay. So last one plus 5.
Oh, I can't.
Last term plus 5. 11 plus 5. Plus 5. Plus 5. Got it. Okay, find the common difference. Well, that was pretty obvious. What do we do between all the terms?
Add
5. I don't even know why I'm writing that, but okay. And then it wants the nth term. So it wants the formula, the AN style formula. So off our formula sheet, off the board over there, it's the first term, n minus 1 times our difference. And of course, if I have to give the formula, I always simplify like any good mathematician would. We would never leave like the square root of 27 in an answer, right? And again, we like to have that formula because now if I ask you for the 1,000 term, you pop 1,000 in there and you can get it for me. Or whatever term I ask you. All right, so last thing we're going to do, last formula really, is adding the terms up. Now, like I said, if you just have a handful of terms, like 7 terms, I mean, I can add 7 numbers pretty quick in my calculator. If you have a lot of terms, like 1,000, I'm clearly not going to add up 1,000 numbers in my calculator. You're out of your mind. So we're going to use this formula here that's on the board. Let me click the slide. Here we go. So for this formula, of course, you know A1 is the first term. N represents your number of terms. So if I want the sum of the first 1,000 terms, N is 1,000. A1 is our first term, and AN, of course, is the last term. So if I want the sum of the first 1,000 terms, the last number here is whatever that 1,000th term would be, rows. But we just showed how to find that if we needed it. Okay, a little vocab here. Some of the first n terms is an infinite sequence called the nth partial sum. We've seen that phrase before. If I want the sum of the first 8 terms, that's the 8th partial sum, they'll call it, of course. And we're going to use our formula. Here we go. Now, this is what I said. I mean, I feel like I could just add those on the home screen in the calculator pretty quick, okay? All right. But I'm going to show you how to use the formula, just of course, in case we have some larger number sets. So, first question for you, easy question for you. Total it up. How many total numbers do they want you to add? What do you got? 7. So, little subscript 7, just saying we're doing the sum of the first 7 terms. So, 7 terms over 2. And then remember, it's the first term, which I'm just looking at it, it's a 1, plus the last term, which was 19. So, I'm going to do 7 halves. Actually, we don't need a calculator. What's 7 halves times 20?
I did that all my
70.
Okay, but you don't have problems adding.
Now, is that any quicker than me just typing on my home screen 1 plus 4 plus 7?
No.
I don't know. I don't really know that it is, but I for sure would want to use my formula when we get to letter C. Same thing on this one. I mean, I feel like I could just add those up pretty quick on the home screen of my calculator, but if I'm going to use my formula, there's 1, 2, 3, 4, 5, 6 of them. 6 over 2. First term's -2, last term's -19. So I'm going to have 3 times -21 for a grand total of, or 17, sorry, 17. I miswrote that. Why did I get put 19? Oh, I was looking at the last one. I made 17 because it's one of my favorite prime numbers. There we go, -57. Again, I don't know if that's any quicker than just straight adding the numbers. Probably not. Actually, probably not. I don't think it is. I type fast. Okay, this, I don't know about you, but I feel like I'd be pretty slow at adding up 50 different numbers, right? So that would take a lot of time. So I'm for sure using the formula. So, first 50 positive even integers. So they want you to add 50 numbers. We can start with that. Okay, this is going to be a fun talk. What is the first positive even integer? 2. Nobody said 0. I'm happy. Why? 0 is considered neutral. Neutral. It's neither positive nor, or it's neither even or odd. Okay, so first positive integer would be 2.
So then we go to 52.
What is the 50th positive even integer? Ooh, which is it? I heard 100, I heard 102.
It's 100.
First one?
What is the 50th positive even integer?
Yeah.
Elliot, I'm hearing everything you say. Like, it's 100. It's 100.
Is it 102?
She just says 108. What are you saying?
All right, punch that in your calculators. I did it earlier. Get a little bigger number on that one, 2550.
Why is it not 102? That's dumb.
So, I love your positive attitude over here, by the way. So it would be like 102, okay? Because remember, I think what's maybe throwing you off is you're not starting at 0. So the first term's 2, 4, 6, 8, 10 is the fifth term.
I was there.
A little hand counting there for you. All right, home stretch. You know I love a word problem. Don't count up to 100. That's too time consuming. Oh my gosh. You know I love a word problem. Okay, an amphitheater. Do you know what an amphitheater is?
Isn't it like a theater?
Like an outdoor.
Oh yeah, they at the Milwaukee they have.
Yes. Okay. 50 rows. Okay. All right. Here we go, people. Focus. Let's get it done.
Let me tell you.
50 rows with 30 seats in the first, 32 in the second, 34 in the third, so on and so
Goes
forth.
up by 2.
Goes up by 2. Find the total number of seats. So we need the sum. So clearly I'm going to use the sum formula. I do not want to have to add all these numbers by hand. Now, you know I can't help myself. Our first row has 30 terms. So I'm thinking, okay, there's like my first term would be 30, and we already figured out they're going up by 2. Your common difference. So I'm thinking about my sum formula here. And there's 50 rows in it. Over 2. I know the first row has 30 rows, 30 seats in the row. The question is, how many seats are in that last row? The 50th row. Now, I don't know if I want to keep adding 2, 2, 2 all the way down to like, you know, the 50th row. You could use your formula. So the first term, n minus 1 times that difference, and then put a 50 in. So calculate that out. What's 30 plus 49 times 2? 128.
I used to have 1/3. No, I said that.
So I'm going to go over to my sum formula now and fill in that my last row has 128 seats in it. And then put that in your calculator. You get a big number, which I can't remember, gotta look at.
1,950.
You got it.
Good job.
3950. And because it's a word problem, I'm gonna label.
Seats.
Feeling ambitious today.
Seats in the Avery.
How many of you took about
Yeah.
Seats in.
That's a lot of seats, I feel like. Maybe not. I don't know what an amphitheater has. Okay. Any questions on that, guys?
Oh, I thought you were saying this.
All right, final one, everybody.
My tattoo do you have?
How many terms of the arithmetic sequence, 579, must be added, oh Lord, to get to 572? Huh, okay. Well, let's write down what we know. We know the first term's 5. You know the difference. What's your difference? Difference is 2. Okay, now here's the fun part. We want to know how many terms am I going to add to this sequence so it gets to a total sum of 572. So I want the sum to equal 572. So I'm like, okay. So I'm thinking about my sum formula here. I know the first term's 5. I feel like I should have spaced that out a little better. But of course the problem is you don't know the last term. So we have no idea. So here's what we're going to do. We're going to use our formula. So first term, n minus 1, it's difference of 2. Let's clean that up. Let's distribute it, make it look good. So I'm going to have 2n plus 3. Now, if I knew we were doing like the sum of the first, 80 terms, I'd put an 80 in there and I could tell you the last term. I do not know that there's 80 terms of the sequence. I have no idea. I'm trying to figure it out. So I'm going to put in here 2n plus 3, which looks crazy. I'm well aware. And then, of course, in the front, let's put the over 2 in the n. Because we're trying to figure out the n. How many terms are we putting into the sequence? Now, that's kind of a hot mess. We're going to have to solve with some algebra here. I'm going to combine the 5 and 3, of course. Let's start simple. So I'm going to make this 2n plus 8. I know nobody loves a fraction in here but me probably. So let's clear out the over 2. I'm just going to times each side by 2. So I got to look. What's 2 times 572? I punched it in earlier. 1144 on the tip of the tongue. And I'm going to distribute the n through 2. So 2n squared, 8n. Now, I see that squared, and I'm thinking, oh, Lord, we're probably going to have to factor it, okay? We got some big numbers here, but they're all even. So I would reduce them. Let's divide them all by 2 just to make our life a little easy. So if I divide that 2, it puts me back to 572. N squared, 2 goes into 84. And of course, we know how to factor. Before we do anything, I'm going to set it to 0. So I'm going to subtract the 572 over. Well, this is going to be a fun question. What 2 numbers multiply to negative 572 and add to 4? Don't all yell it at once.
Let me just.
Wait.
Now, remember, I got to tell you, I wouldn't try to guess and check on my calculator with that large 572. Use your table and your graphing calculator. Do you remember how to put that in?
No.
Yes.
Hang on, Brooklyn. So in your y equals menu, we want to figure out what goes into negative 572. So I'm going to hit divided by x. That tells you what divides into it. And then scroll through your table and look for a combination of whole numbers. What do we have to add to add to 4? And if I scroll this down a little bit, you're going to see them. There we go, 22, 26. Which one's negative? So, okay, key question, are you ready? What are your 2 potential answers for n? 22 and negative. And I already hear mutterings. So which ones do we think that I have an issue with? Yeah, because we're trying to figure out the number of terms. Got it. n equals 20. I'm going to write it up pretty. N equals 22 terms. That's the worst thing you had to do, stand real fast, right? Avery. I suppose. I thought you were going to have a more exciting question. All right, let me grab your homework for you. I thought you were going to have something way more exciting. Always, always. Okay. Use your formula sheets, of course.
You know what? I'm gonna do it.
Did you guys lose your crayons, or what's happened over here? Yeah, what's happening now here, Grayson?
I'm trying to repair a pen that somebody dismantled.
I don't know.
Stop clicking your pencil to the leg.
I knew that.
Yeah, Alicia. It's a lot. It's a little. It's a lot.
Obviously. That's exactly what I thought it was.
I got to 725.
That's 4 pages.
I wasn't counting.